Welcome to this tutorial. I'm going to describe my workflow using my one-shot color camera, the 533 MC Pro, and the monochrome version 533 MM Pro. This is going to be a workflow to combine colored stars with hydrogen and oxygen data. First, I'm going to go through that data. We have three sets here. On the left-hand side, I've got a 25-minute data set from my one-shot color camera. That's just to get the colored stars. You can see I've not calibrated that data set because it's got a noticeable dust spot, but that's not important. That won't show up in the final image. And also on the middle and the right-hand side, we've got the monochrome camera data. This is about 3.5 or 4 hours worth of hydrogen alpha data in the middle and oxygen 3 data on the right-hand side. So the first thing that we're going to do is we're going to reorientate the star data set just with geometry, 180-degree rotation. It's not essential, but it will help with the alignment process that happens next. The next point then, we're going to align both the oxygen data and the colored star data to a common frame of reference, which will be our hydrogen alpha data. We're using the star alignment process. The reference image is our hydrogen alpha data set, and we've selected the two target images there. We hit the circle, and both those will be registered. And finally, I'm going to rescale the data by 50% because I use dithering and drizzling, and this is just to get the data into a more manageable size. So moving on to the exterminators, we're going to talk about the blur exterminator first. Now, one option here is to find our own PSF for the stars in each of the data sets and use that as our entry for the blur exterminator. This is what I normally do. I'm just showing you that quickly. But for this example, I'm just going to use the default setting in blur exterminator as set at automatic PSF. And I tend to use a 0.5 level for the sharpening as well. Now, these are the three data sets just zoomed in to the same corner of the image before the blur exterminator. And then afterwards, you can see once the blur exterminator has been applied, it reduces the stars quite considerably in each of the three data sets and sharpens up some of that nebulosity as well. Now, the next thing we're going to do is run noise exterminator, but I'm deliberately going to avoid doing that for the hydrogen alpha because that to me looks quite noise-free as things stand. And what I tend to do is use a 0.7 value for the noise level, for the denoise level there. We're now going to talk about how we deal with the stars. And firstly, we want to extract a star mask from the one-shot color data and then stretch that data in a linear fashion. So we're going to start off with one-shot color data. We're going to use StarNet. We're going to make sure that create a star mask is ticked as well as linear data is ticked. And you'll end up with an image that you can see in front of you like that. Now, at this point, it's very important to reset the STF, otherwise further stretching won't work, and you'll end up with a black image. You should end up with a black image as you see in front of you at the moment. We're now then going to stretch the data with 2 runs of arcsine stretch, and this is deliberately to try and extract the color in the linear data. We start off with a value of 10, and when we move on to a value of 5, and these can be adjusted as you see fit. And finally, we'll end up with a curve stretch, and the stars should look something like that in the top left. We're then going to remove our stars from the oxygen and the hydrogen data, and we can do that either in linear fashion or we can do it after a histogram stretch, as I've done in this case. Now, all our data is now stretched, and we're moving into non-linear territory. So please join me for part 2, where I discuss the rest of the processing.